All right, cool. So let me tell you. First important thing. Next week will be a week of quizzes. Quiz in chapter 4. Man, I shut you guys up. 19.
I'm gonna die. Okay.
And a quiz.
That's cute. I saw my friend
Chapter 5, 6162. Wednesday. Actually, first. If you're smart, you're realizing that that's a good thing. More grades is good. Less grades is bad. So you're welcome. Welcome.
Okay. I appreciate that. Yeah, me too.
Can you guys tell me real quick what chapter 4 was about? Chapter 3 is probability.
Chapter 4 is like a C thing, right?
Oh, yeah. So part of chapter 4 was a sea thing. Right? Not like boats in the sea, but that shoes thing. And what was the first part of chapter 4 about it? It was another table, but it was X.
No, Mars.
X, P of X, that stuff? All right. On quizzes, I just put the formulas on the quiz, so I'm not going to worry about a formula sheet yet. That's for tests. So formulas will be on the quiz. Chapter 5 was the uniform distribution for the most part, and then had a few just general continuous distribution ideas. And then 6162 is what we're going to do today. So we should get done with those today. We'll see what happens. So first question for you guys is, any questions on homework stuff? It's the quickest way to quiet the room down, man, I tell you. No, okay. All right, I'm an optimistic fool. That means everybody's doing their homework and it's going fine. I love it. Okay. Guys, so I think last time we finished that. Let's see. Did we? Yeah, we did. We finished that handout I gave out. Did everybody get one of those? Did you get your quiz back? What's your name?
Tim.
Timothy?
Yeah.
Ah, there you go.
I'll learn from
Alright, cool. So if you weren't here for that, you've always got the video you can go to on the YouTubes. So if you go, there's a link on the website. Okay, so we finished that one. That was, the latter part of chapter 4. And then getting into chapter 5. Really. Cool. We basically finished chapter 5, but there's a couple things I'll put up here just so you see them. There are some homework questions about the mean for a uniform distribution. And the standard deviation of a uniform distribution. But what's your gut tell you should be the mean of the uniform? So if I had like times that were from 5 to 15, and they're uniformly distributed, first off, what's the height of that uniform distribution? 1 over 10. All right. As the width is 10, 1/10 would make the area 1. That's what makes it valid. What are the averages? What's the average if you have to wait between 5 and 15 minutes until they come tell you results of your blood test? I don't know. What's the average time you'd have to wait? 10 minutes. I love it. So what's the general way to say that then? It's just going to be take the what of those two? Average, eh? Holy shit. Okay. Wow, that's people up there. I just there's a nice calming scene up there for you. So in general, if I call this A, and if you've done any of the homework, you are used to this. That's A, and that's B. Then the average will just be A plus B divided by 2, the average of those two extremes. It's uniformly distributed, so it's all equally likely. I like it. And what about the standard deviation? Now this, 2 semesters ago I had a class. I'm just going to show you the formula. If you want to see the proof of it, I can print out the same thing I gave out to them. And they're like, oh, okay, because it's based on some calculus going on. The standard deviation for this guy is the square root of b minus a squared over 12. And I love that the most common question I got was, why 12? I love it. You have to see the derivation. But please understand, I'm not even going to ask a question about these on the test or a quiz. But you do have to have these just so you can use them for the homework. I want you to know they exist. Yes?
Is the 12 in the square root?
Yes. The big old square root.
Okay.
Over everything. I like it. Some of you guys might realize this would just be b minus a over the square root of 12. Right? Because you square root the square. But anyway, that's the formula for the standard deviation. A lot of you guys seem to believe as students that if it's not on the test, it's not important, and that's bullshit. Right? This is not on the test because it's not used that much, but it's good to know. Whatever the distribution, I should always be able to figure out a mean and a standard deviation formula for it. Because those are the 2 most important numbers to be able to calculate about a set of data. Okay, I like it. Bless you. Anything about that? Is that cool? I'm not going to ask you questions about it, but still for the homework, you got to be able to plug some stuff in there. Okay. Okay. That's the last little piece of Chapter 5 I wanted to talk about. So if there's no questions about Chapter 5, yes?
So Chapter 5 is mainly about that, right?
Chapter 5 is mainly about the uniform distribution, but 5.1 talks about other continuous distributions. There's one called the exponential distribution. But they don't ask you to calculate any probabilities because we don't actually get into its formula. But it's just to show you that there are other forms for continuous distributions.
And then Chapter 4 is the binomial problem.
Chapter 4 is the sum of x, the xp of x, and then the binomial stuff. I like it. So this is going to be the xp of x stuff. The NPQ problems is what I call them. NPQ problems, right? All right, I like it. So anything about everything we just heard or were witness to? Is that cool? We're going to get into Chapter 6 now, which I think I told you last time is one of the most important chapters in the book. Everything after this is going to be based on what we learned in Chapter 6. Almost everything. All right. So I want to refer you back to the handout from last time, just to remind you guys one little thing. I'm not even going to put it up there. The very last thing on this side was talking about the normal distribution. And if you recall, we talked about why we can't do problems with the normal distribution as easily as we can with this. Any sub-area of this is going to be a rectangle. Do I need help finding the area of a rectangle? No. If you do, you're in the wrong class. Get out of here. Right? So rectangles, easy as shit. There's actually other distributions that are like triangles. So I can have a distribution that looks like this. And then if I have to find a subsection of it, that would just be a triangle, right? So I can get the area of that, half the height times the base. No worries. Are you with me? Okay, cool. So if the distribution has a shape to it that I can just geometrically get the areas, I'm golden. But what's the goal? When I have a picture like this, how do I answer a probability question? I find the area related to the question. Is that decent? You guys with me on that? If I say that, is that cool? Are you guys? Okay. All right. So the problem with the normal distribution is the shape is not one that we know any geometry about. Right? We have to actually kind of create it using calculus. We have to use that. We're not going to learn calculus. So here's the normal distribution. Somebody remind me about this. We do know a few things about this from the empirical rule. That's that rule that tells us what's within 1, within 2, within 3. Does anybody remember what's within one standard deviation of the mean? How much? Yeah, 68%. There's no, look at the shape. Look at the shape of this thing. You know, especially with my drawing, but that's not a rectangle. That's not a circle. That's not anything. There's no standard formula for the area of this curvy dude here, right? There isn't. So what we're going to use instead is what's called the z-score chart. What are these? How did I represent these? What do these represent? Beautiful. But more directly, these are what's? Z-scores. I love it, because z-scores are the number of standard deviations away from the middle, right? You guys semi with me? So somehow, if I looked this information up on the z-score chart, it should tell me 0.68. That's what it should come out. That's what should come out of this. Are you guys? That's the first thing we're going to do with the z-score chart, so we sort of buy into the z-score chart, right? And you're like, whatever, man. Let me give it to you. And the very first thing we got to do is figure out how the hell to read it. Ooh, that's purple. That's nice. Ooh, look at you. I like it. Caleb's got one color.
Thanks. Okay, I'm already colorful. What is it? No, I took this stuff. I can't remember. No, I would do no. It's kind of like a review. Like, no?
Okay.
It's just perfect. Okay, end of class. I can even ask questions. So I can ask questions at the end of the class. I'm like, what the fuck does that mean? Am I supposed to ask questions during class?
So if this is your first time seeing this, which I think should describe most of you, then you're not really sure how the hell to look at this thing, right?
But are you just kind of like,
Oh, it's initializing. Let's see if it will let me do this. Yay. Okay, first thing I want you to see is they kind of tell you. Oh, let me say this right now before anything happens. This is your z-score chart. You will bring it with you to quizzes and tests. You will not write any notes on it. You can put your name on it if you like. I'm going to be taking them to make sure that there's no extraneous notes, to make sure that everybody's doing fair shit, right? So if you forget yours, I'll have a few copies. Maybe not enough, so don't forget yours. All right. So this only works for what kind of distribution? Normal. Because if it's not normal, then I have no way of knowing how the areas should be distributed, right? How the hell does this shit work? Let's see. These are z-scores here. That's nice. And notice this. You can barely see this, especially up here. But can you guys see that that's shaded right there? Right? And on the other side, this is the positive z-scores. All right. And it's shaded there. So if I look up a z-score, this chart always tells me the area below that z-score. And what do we know areas actually mean? Since this has got a total area of 1, that area is actually equal to the probability that I get something below that z-score. So if I was like, what's the probability somebody got below a z-score of 2 on the last quiz, I could just look it up here if it's normal. If it's a normally distributed grades, I could just use this chart to see the probability. All right, so to kind of recollect this, and let me show the people at home what the hell we're talking about. What are they talking about? All right, you better be sick if you're at home. Especially with this shit. Okay. If I want to recollect this, I turned it around just in time. How do I look? All right, let me see if you guys can get this. This area is between these two z-scores. Can that chart handle that kind of thing directly? Is there any way to look up in between? No. But I can look up how much is below this z-score, right? And I can look up how much is below that z-score. So let's do that first. I'm on the positive side of the moment. I love it. So that's going to be 1 point. How can I rewrite 1 to 2 decimal places? 1.00. So it goes to 2 decimal places. If I wanted to look up 1.03, I would go 1.03. You guys see that? That's 1.03. That's the area below a z-score of 1.03. That is how you read this. So if I wanted 2.18, what's the area below 2.18? I would look at 2.1, 8. There we go. 2.18, bam. So I get 0.9854. Does everybody see that? It's not that huge of a thing. Do you have something in your life that works like this? No. We're all humans. We can figure this shit out. If I want 0.96, I go to 0.96, and that would be the area below that z-score. Okay. So why does this make sense? If you look at 0.00, why does it say 0.5? What does that mean? Why does that make sense? What's 0.00? That would be the middle, which is better known as the yes. And what area is there below the mean? The mean cuts it in. There you go. It's 50% below the mean. That's what that means. Kick ass. So what area is below 1.00? 1.00. 8413. I like it. So there's 8413 here. Now you guys look up negative 1.00. There you go. I like it. Flipping has to happen. So look up negative z-scores.
0.1587.
That sounds familiar. 1587? Now how do you get the area in the middle? We're trying to verify it's about 68%. Subtract it. It makes physical sense. Is this too much or not enough compared to what I want? I want this area. Is this too much or not enough? Too much. How much too much? Exactly this much too much. Right? I want to stop here. So if I take this minus this, I'll get the area in the middle. Please let that make complete physical sense. Right?
Wait, that one and that one?
Yeah, the only two we have up there. No, the one I wrote in invisible ink there. So what is 0.8413 minus 0.1587? 0.6? 8? 2? 5? 6? I think. Sure. 6? Okay. Which, if you round it, it's about 68%. It's 68%. That's the empirical rule there. So this is the empirical rule on steroids, right? This is just, it doesn't just go 1, 2, 3. Now we can get all these things in between. How are you guys feeling so far? So do me a favor, let me see. Here, let's do a couple real quick. Can you figure out the probability that z is less than negative 1.92? Try to look that up on the chart. Don't say anything out loud. When you find it, just feel excited for a minute. Oh, turn you around. All right, wait. Somebody got that? No, okay. Negative 1.9. 2. You got to be careful. Now watch. Something that people do a lot is they go negative 1.912. No, this is negative 1.90. Negative 1.9012. So 0.0274. I like what I always highly recommend is you draw the picture. What's in the middle for z-scores? What's in the middle? What's in the middle for z-scores? The mean, which for z-scores would be 0. Where is negative 1.92? Down here. I love the people that just throw it wherever the hell they want to. The whole purpose of drawing this picture very quickly is to make sure the answer makes sense. You good? Okay. So shade in the area that I want. What area do I want? I want this area, the area below negative 1.92. Cool? And then put areas up here, z-scores down there. Trust me, because z-score, like if the z-score is 0.37, that looks like 37%, but it ain't. It's a frickin' z-score, so they look like each other. That just is evil, but too bad. It's just the way it is. So put z-scores here, areas up here, just so you don't mess yourself up. All right? And what we just found, completely out of my head by now, 0274. Which would be what as a percentage, if you wanted to? 2.74%. Yes?
Okay, so negative 1.92 is greater than, why did you shade that side?
No. I want the probability that the z-score I get is less than negative 1.92. And where the z-score is less than this,
Oh, okay, no.
below it. I love it. So remember, you shade the direction the arrow is pointing, right?
Okay.
That's how inequalities work for shading. Kick ass. All right, let's do this one. What is the probability that I get z greater than 0.18? Oh shit, I highly recommend drawing the picture and shading. Again, we're just starting to do this, so don't beat yourself too much yet.
And you always write down 100%?
Yeah, you can either write it. Now, do you guys see now? I forgot to say why I was getting you to do probabilities to 4 places. Just getting you used to it so you could see when you see this chart, it makes sense. And if you want to change it into a percentage, that's on you. You can do it or not. I don't care. I like it. Don't care. So you can stop here or you can go there. I don't care. So what's this look like? Where would the, and again, in the middle is 0. 0.18 would be where? Up here a little bit, right? And you can be nice to yourself. It doesn't have to be the scale or anything. We're not really even sure what the scale would be exactly. And then I want the area above it, right? To the, right. So I want this area. When I use the z-score chart, it will always tell me the area that is below. So let's see. Let's look up. If you know a shortcut, just hold it for a minute. I'll show you the shortcut, and then I won't ever talk about it again. So if I look up 0.18, what do you guys get? 5675? Oh, 5714. There it is, Jeff. 0.18, 0.5714. So that's where?
Yeah.
What? This way. 0.5714. Why does that make sense? See how 0 cuts it in half. So if I go a little bit above 0, I've picked up a little bit extra area. That makes sense. So this answer, my real answer, this is not my answer yet. My answer should be less than 50% because I'm a little bit above the mean. So how do I get this side? How do I get the answer? Yeah, the whole thing is 1. I don't want that side. I want the other side. So 1 minus this. 4286. All right, let me stop there for a second. How do you guys feel about that? Since the chart always tells me areas below z-scores, the questions that have a less than will be easy. The questions that have a greater than or between, I've got to do a little bit of work on. Now do me a favor real quick. Can you look up negative 0.18? What area do you see? What do you see? 4286, I know, yeah, right? Because the area, now watch. If you don't get this, I don't care, because it's not that big of a shortcut. It's a tiny little shortcut. The area above 0.18 should be equal to the area below negative 0.18 because of symmetry, right? It's symmetric. Boogie boogie. So, I mean, that's a little tiny shortcut. But just like your car blinkers, if you're not sure when to use them or if you forget, then don't ever use them. Right? I love you people that are like, have your blinker going that way and then you go this way. It's like,
Same.
whoa, that's a machine gun laugh. Sorry, I had to call it out. I didn't mean to make you feel uncomfortable. I just thought it was really cool. All right, so I think you guys are ready for this. Let's find out. Oh, here it is. So on this, I just want you to do number 1 on this handout. Do these problems. You can work with somebody if you want to. Just worry about problem number 1.